Hello everybody, today we are going to talk about bitwise operators. Before we start, I would like to mention that this topic is not easy for most of the programmers, so don't worry if you don't understand it. However, it's a good idea to watch it and know about existence of something like that. Okay, what are bitwise operators? Bitwise operators are created to work on bits. I will remind that bit is the smallest information that can be stored in our computer, and it is represented by, let's know that, 0 and 1s, right? And the 0 or 1 can be connected. For example, 8 signs of connected bits is called byte. So for example, sequence something like that. And if we want to operate on that 0 and 1 signs, we have to use bitwise operators. Look, every number is stored in computer by using that 0 and 1 signs. Computer notation is surprisingly very similar to our notation, which is called decimal notation. Let's remind it. For example, number 126. This number is really created of something like that. 1 multiplied by 10 raised to the power of 2 plus 2 multiplied by 10 raised to the power of 1 plus 6 multiplied by 10 raised to the power of 0. And as you can see, that thing here is equal to 100, that thing here is equal to 20, that thing here is equal to 6, because 10 raised to the power of 0 is 1, right? So 1 multiplied by 6 is 6. Okay, and you might be now like, why am I saying this? It's because if you want to change computer notation, which is called binary notation, we must do the same thing. We need to understand the changes to understand bitwise operators. For example, let's change something like 1010. This thing is something like 1 multiplied by something plus 0 multiplied by something plus 1 multiplied by something plus 0 multiplied by something. As you can see, I am writing what? Just the numbers here, right? And if you look above, I was writing also that numbers here, as you can see. Okay, and now we need to write what? We are using here 10. Why 10? Because here is a decimal numbers. So we are counting to 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. And that are 10 numbers already. We have 10 fingers, right? And that's why here is 10. In computer we have only two numbers, 0, 1. So here we will multiply by 2. Multiply by 2, multiply by 2, multiply by 2, multiply by 2. And now, as you can see, I was rising to the power of what? Look, here is the position number 1. Here is the position number 2. Here is the position number 3. So, as you can see, that numbers are decreasing. 2, 1, 0. 3, 2, 1. So, this is the number of position minus 1. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. Okay, so here how it should be. 2 raised to the power of 0, 1, 2, 3. Okay, so to the power of 3. 0 multiplied by 2 to the power of 2. 1 multiplied by 2 raised to the power of 1. 0 multiplied by 2 raised to the power of 0. And now that thing here is decimal number. So 1 multiplied by 2 to the raised to the power of 3 is 8, plus that thing here is going to be 4, but 4 multiplied by 0 is just 0. So 0 plus 2 multiplied by 1. So it's 2 plus 0. So 1010 is really, in our word, in decimal notation, 10. Okay. You should also notice now that when you see 0 in binary notation, you can pass it, because anything multiplied by 0 is just 0. So why do so many things? You can just remove it, right? And now it's a bit shorter. And again, you should also notice that anything multiplied by 1 is still the same number. So we should focus on which place is that number and raise 2 to the power of position minus 1. So we should just do something like that. And now it's very short, right? And let's use the thing that we have just learned about. And for example, I have 1 0 1 1 0 0, and you should think like that now. Here I have 0, so I don't need to think about that situation, because anything multiplied by 0 is 0. But normally here is hidden number 1, if 0 was 1, right? And now again number 0, so I will just pass it, but I remember that if it was 1, there will be number 2 in decimal notation. Okay, now I have here 1, and now I know that I should raise 2 to the power of position minus 1. So what position is it? 1, 2, 3. 3 minus 1 is 2. So 2 to the power, 2 raised to the power of 2. So I have 4, right? And I memorize it somewhere, or I'm just writing it here, right? And now plus 2 to the power of 3, because I have got here 1. Now I have 0, so I know that here will be 2 raised to the power of 4. Here is 2 raised to the power of 5, plus 2 raised to the power of 5. So it's what? 4 plus 8 plus 32. So it is 44. In Windows 7 we can use something like binary calculator, and now when I write here 44, as you can see, we have got here 1 0 1 1 0 0. So I was right. 44 is in our computer set as 1 0 1 1 0 0. But as you can see, also before that 1 are many zeros. Okay? Okay, now we can learn about the bitwise operators. Before we start, I'd like to mention that I'm assuming that you understand lesson about relational operators very well. Okay, let's start from making multi-line comment, and let's start from bitwise and operator, which is 1 ampersand. It works like relational operator AND, but remember, this time we are operating on bits, not on the results of expressions. Okay, we have got also bitwise OR, which is 1 pipe, and it works like relational operator OR, but this time again we are operating on bits, not on the results of expressions. We have got also bitwise operator NOT, which is tilde, and it works like relational operator negation, which is exclamation mark there, but this time again remember that we are operating on bits, not on the result of expressions. And there are 3 more operators here this time. Bitwise exclusive OR, which is caret, exclusive OR because it looks like that, right? It's abbreviation for exclusive OR. And this thing is also called exclusive disjunction. Exclusive means here that we cannot have more than one alternative to choose. So table for XOR is 0, 0, which gives us 0 because we don't have any right alternative to choose, right? Because we have only 0, 0, so what to choose here. 0 and 1 will give us 1 because we can choose the right alternative here, for example that guy, and 1, 0, which gives us 1 because we can choose the right alternative here too, for example that guy, and 1, 1, which gives us 0 because we cannot choose more than one alternative in exclusive OR. There can be only one right alternative at once, so it must be exclusive, okay? That's so it's a bit different from that guy here. Okay, we have got also something what is called bitwise left shift operator, which is two angled brackets pointing to the left. They are used, as the name suggests, to move bits to the left, but we'll explain it more clearly later. We have got also bitwise right shift operation, which is two angled brackets pointing to the right, as you can see, and they are also used, as the name suggests, to move bits to the right, and also we'll explain it more clearly later. Okay, now it's time to do some exercises. For example, cout and 10 and 2, and we want to see what will be the output. Okay, let's do something like that. Look, normally 0, 0, 0 is just 0, right? If I want to change that thing to 10, let's do something like that. Here normally is hidden 1. Here normally is hidden 2. Here normally is hidden 4. Here normally is hidden 8. So 8 plus 2 will give us 10. So I change this guy to 1, this guy to 1, and this thing is 10, right? Now I think about that 2 here, so it will be 0, 0, 1, 0. And now we have got here 10 in decimal, and here 2 in decimal notation, when I change it from binary notation, of course. Okay, and now we have just used something here, what is called AND operator. And the AND operator, bitwise AND operator, it's working like relational operator, as I said. So when conjunction is true, only when both arguments are true. So 0, 0, and this thing is 1 because we have got here true, true, and 0. So what is going to be here? It should be 2. As you can see, the result is 2. Okay, now let's try the OR bitwise operator. So operator OR is working like what? It is false only when both arguments are false. So here is true, false, true, false. So the result is, as you can see, 10. It's working well. Okay, now let's try the alternative OR, exclusive OR, I wanted to say, sorry. And now how it works, we can see here. So here is 1, here is 0, here is also 0. So the result is what? 0 plus 0 plus 0 plus 8. As you can see, it is 8. Cool. Now let's check the negation, the not bitwise operator. For example, let's do 10 and now something like that. And now 1010 should change to 0101. And you might be thinking that the result is what? 1 plus 4 is 5. But the result is minus 11. Why? As you have noticed probably when I was running that calculator here, look how many zeros we have here. So here is so many zeros, and that many zeros are changed to 1, right? Also. And in programming, if you want to achieve the minus number, the first guy must be 1. The first number here is indicating that the number will be, as you can see, negative. And now we are decreasing it, right? Okay. Well, maybe I should have said increasing, because when we are on negative side, it's working different way. Well, never mind. Now you can see why we have got here the negative result. Okay, now let's talk about cout and that shifting guys. That guy's here, right? So, for example, I do something like that. 10 shifted one time to the left side. And what the hell is that? Look, for example, I have that guy here, right? And I am saying, hey, move to the left side. So, this guy here will be moved to that place, so that guy will be 0, but the guy that was here is moving here, so 1, 0, and now 1. So right now what happened? We increased that number for sure, right? But by how much did I increase that number? We are all the time doing something like raising number to the power of 2. So 2 to the power of 0, 1 to the power of 1 is 2, 2 to the power of 2 is 4, 8, 16, right? So 16 plus 4 is 20. So the result will be 20 in decimal notation. And if I did something like that, I would have one more time that bits shifted to the left side, and we would have 40 here because we would multiply it by again 2. So this thing means that we are multiplying by 2 raised to the power of that thing here. So this thing means that we are multiplying 10 by 2 raised to the power of 2. This time it's 2. Let's write maybe 3. Okay, to the power of 3. And so 10 multiplied by 2 to the raised to the power of 3 is what? 10 multiplied by 8, so I should have 80 here. Let's see if I'm right, if I'm not lying, and as you can see everything is working fine. Okay, so if I'm doing it another way, so that way, that we are dividing 10 by 2 raised by something. So let's divide by 2 raised to the power of 1. So I am dividing by 2, 10, so the result should be 5. This time we are moving it another way, so this thing will be changed to what? 0, 1, 0, 1. So it will be 1 plus 4, 5, right? Let's check it out. Sorry, of course, we should change that guy to the right. And now it works fine. Okay, it's 5, everything is okay. That's all in the lesson. Thank you very much.